Hi, this is a delicate instrument handled with extreme care. First, Happy New Year, because when you will see the video will be in 2021. So this is the last day of this year. Today we will do a teardown of this instrument. This thing is quite heavy, 2 kilos approximately, maybe 3. As you can see, this is an EPR transducer. EPR stands for engine pressure ratio. Normally we should have 2 inputs pressure, but on this instrument obviously there is only 1 input, which is this inlet here. So you can see the reference of this instrument if you want. And on that side there is a classic circular connector. There are several screws on the cover, and you can see that the screws are very special. You need a special screwdriver. You can see just a few seconds on this image the pressures which are measured normally. So the input pressure is here, and the input pressure is normally PT2 probe. PT2 is the name which was written on the hidden plate of this transducer, so this is probably only the input pressure, but normally an EPR transducer like this one here has 2 input pressures, the input pressure and also the exhaust pressure, and the instrument measures the ratio between these 2 pressures. The sensors are normally very close to a pitot tube sensor, so we should find inside this thing something equivalent to an airspeed transducer or an altitude transducer with a servo mechanism, a motor, and probably a capsule, or maybe something else. I don't know. I don't know also if there is some electronics inside. So let's open this thing to see what is inside. Okay, so let's see what is inside. Oh, I didn't expect to find such electronics inside. I think a little reverse engineering will be required. So let's have a look on the electronic side. You can see that we have 3 nice capacitors here. 300 microfarads. This one also. This one is a 70 microfarads. We have this transistor, so that code 78 in TO66, and we have 2 op-amps here. That code 78 also. And this seems to be metal foil resistors with very specific values, as you can see. Normally they should be 0.1%. Yes, you can see 0.01%. These are metal foil resistors, maybe S102J or something like that. And here there are several transistors, a classic one to N1893. The other one are difficult to see. This one maybe TO39. They have military specifications. They have the prefix GAN. I cannot see 2219. Yeah, so this is the classic 2219A. And this thing can be removed, as you can see, in order to get access to the electromechanical stuff. Okay, so this thing is very strange. This thing are a kind of suspensions. Yeah, there are some silicone stuff. So this thing is mechanically isolated from the frame. And this will be difficult to understand because it is difficult to see exactly how this thing works. It is difficult to see, but there is also another PCB here. And there is this black stuff here with 4 wires. You can see that this thing is a kind of screw. There is another one here you can distinguish. So probably this thing can be removed. Probably this thing permits to remove the screw from that side, I don't know. Okay, so this is just a seal. And it is effectively possible to remove the mechanical stuff. I think that the torque is very high. Yes, okay. So I will need a few minutes to remove these screws. Okay, so let's see what is this mechanical stuff. It is not possible to remove the tube. This will be difficult. Okay, so obviously this thing seems to be a position sensor, probably an LVDT. I will try to zoom in. So there is some kind of servo control of this position. This thing is quite difficult to manipulate because of the wires and also because of the tube. It can be maybe better to remove that screw here. This will liberate this harness. Okay, this is better. Can have a better view on this thing. And this thing seems to be a voice coil. And we have two kinds of capsules here. The pressure input is fed to this kind of capsule, like an accordion stuff. And there is another one here, which is connected to nothing, actually. As you can see, the tube is closed. And this thing is a counterweight. This thing balances the weight of the voice coil, so you can see the two wires of the coil here. So as you can see, when this thing moves, there is a change of the volume inside this thing. So this permits to have a regulation of the position of this thing. And the second one permits probably to have a kind of compensation with temperature. The second one should have a reverse effect regarding the first one. The last thing is this board in the middle. I don't know the purpose of this one, because we have everything here. We have the voice coil, which permits to regulate the position of this lever here, according to the sensor here. But I don't understand this stuff in the middle. And this thing is spotted. It seems to be a transformer, actually. The transformer is probably a part of this system. It is maybe connected to this LVDT sensor here. So we should find a magnet inside this thing here. Yes, it is obvious that there is a magnet inside, and a strong one. Actually, it is like a loudspeaker. There is a coil inside the magnetic field, and this coil is probably driven by this power transistor here in TO66 package. The second step will be the reverse engineering of this board. First, I will draw a small schematic in order to see where are going all these wires. There are 2 wires for the voice coil. There are 4 wires for the LVDT sensor, and the remaining wires are connected to the transformer. After that, it should be possible to make it work. Thanks for watching and see you next time. Bye bye.